Okay, here's the solution for page 1 of the mock for unit circle core. First of all, I'm going to go over what we have at the top of the test here. First of all, we have the formula for area of a circle, which is pi r squared. We have the formula for the circumference of a circle, which is the distance around the circle, 2 pi r. And we have a sine, cosine, tangent data table. Let me show you how this data table works. It kind of works like your calculator, okay? So let's say that you want to know the sine of 30 degrees. So on your calculator, you might put sine of 30 degrees, and you would hit enter, and it would tell you 0.5, right? So on this table, we have all the sine, cosine, tangent values that are necessary for this test. And the way you do it is you put sine of 30 degrees. So like I have sine, and I have 30 degrees. So sine of 30 degrees. And we can see that they intersect at this value, 0.5. So sine of 30 degrees gives me a value of 0.5, just like I saw on the calculator, right? Now what if I put like tangent of 60 degrees? So what is the tangent of 60 degrees? It's 1.73. So if I look at my table, the tangent of 60 degrees is indeed 1.73, right? So that's how you use it. You figure out, do I want sine, cosine, or tangent? And then you look at what angle you want to look at, okay? All right, now I'm going to show you one more thing. You could actually use it to find inverse sines and inverse cosines also. So like, for example, if I have 0.5 and I want to know the inverse sine of 0.5, watch this. I'm going to do second sine, which is inverse sine of 0.5. It tells me it's 30 degrees. So like, let's say that I look up, I want to know the inverse sine of something. So I look in the row for sine, and I find 0.5, and I can see that this is the inverse sine of 30 degrees, right? The answer then would be 30 degrees. So let me erase everything just to make it more clear. Okay, so when I do an inverse sine, I'm going to look in this part of the table for my value, and I'm going to look in the row which corresponds to the inverse function I want to do. So I want to do the inverse sine of 0.5, so I say, okay, I'm going to look at 0.5 in the sine row, and that will give me my answer, which is 30 degrees. Okay, how about if I do inverse cosine of 0.707? So I'll do inverse cosine of 0.707. That'll give me 45 degrees. So let's see, inverse cosine. So I'm looking in the cosine row. I'm looking at 0.707, and that would give me 45 degrees. So it works, right? So this table replaces the calculator for finding sine, cosine, tangent of these specific angles between 0 and 90. And you can also find inverse sine, cosine, and tangents. If you give it the ratios that are in this middle part of the table, you can find which angle corresponds to that ratio, okay? So I'm going to show you again how to use it when we get to a problem which necessitates use of the table or the calculator, okay? And the reason why we're using this table for this test is so that we can make sure that you understand how to use the concept of the reference angle. If we use the calculator might give you the right answer most of the time, but sometimes it's not going to give you the right answer. And so in order for you always to get the right answer, you have to use this table in your brain, okay? All right. So, number 1, use the graph below to find cosine of theta. And it says, what angle is theta? It's this shaded angle here, okay? And it happens to tell us the coordinates of this red point is -8/15 and 15/17, okay? The second problem is a similar problem. It says use the graph below to find the sine of theta, and the shaded angle is here, okay? And it gives us the coordinates of this point, -24/5, -8/25, okay? So let's go back to what the unit circle, how the unit circle works. And just to focus in on one of these here, I'm going to draw a triangle which is made by taking the red point and drawing a vertical line to the x-axis, okay? When I do that, I've drawn a reference triangle, okay? So this reference triangle helps me figure out what the sine and the cosine are of this red point, okay? So, for example, remember back when we did the clock investigations and we figured out all the points on the clock, and we figured out that like this was 1, 0, and this was 0.866, 0.5, and this is 0.5, 0.866, and this one here is going to be 0, 1. Remember that? Okay. Well, we were working specifically with angles that are increments of 30 degrees, but now we're going to work with any triangle within this circle. Okay? But one thing that we figured out when we worked with increments of 30 degrees is that if we wrote down the lengths of the triangle, which is drawn between the red point and the x-axis, that the distances on this triangle corresponded to two things. One, they correspond to the x and y coordinates of the red point, right? So the lengths of the two legs of the triangle, the horizontal and the vertical lengths of the triangle, are the same lengths as the coordinates here, which makes total sense, right? Because the middle of the circles here is 0, 0, and we can see that the sides of the triangle are in the exact right positions to serve as the coordinate distances from the x-axis and the y-axis, right? The only thing that I'm writing not totally correctly here is that I wrote that the distance for this leg is 8/15, the distance for this leg is 15/17, right? But when I write them as coordinates, if I move left or if I move down, that would be a negative coordinate, right? And if I move up and to the right, that would be a positive coordinate. So one of these is going to be a negative coordinate. The one that's going to be a negative coordinate is this one that goes left, right? If I go left, it must be a negative coordinate. Now, 15/17 goes up, so it's a positive coordinate. So you can see why this point has a negative coordinate for x and a positive coordinate for y, right? Okay. Next thing I'm going to do is I'm going to figure out that if I have an angle of a triangle, and this angle of the triangle is here, okay, I can use this angle to figure out the sine and the cosine of an angle which is greater than 90 degrees, okay? So that concept maybe makes no sense because, like, how do you make a right triangle with an angle that is greater than 90 degrees? I can understand how to make a right triangle for an angle that is less than 90 degrees. It would look kind of like this, right? But once you go past 90 degrees, I mean, how do you draw the triangle? Do you draw it like that? And if I draw it like that, it's no longer a right triangle, right? So the solution is that when you pass 90 degrees, you continue to draw the one side of the triangle straight down vertically from the red point to the x-axis like I did here, okay? So that is a right triangle for an obtuse angle, an angle that is greater than 90 degrees, okay? So when you have an obtuse angle, the sine and the cosines continue to have the same definitions as when you had an acute angle. So, for example, they want to know the cosine, right? We want to know the cosine. Remember that the cosine is equal to CAH. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse, that would be the side that is adjacent to the angle, right? Given that the angle is this angle here, the adjacent would be negative 8/15. And we would consider negative 8/15, not positive 8/15, because in this case, it's an obtuse angle, so the triangle is pointing to the left, okay? So the adjacent would be negative 8 over 15ths, and the hypotenuse would be, well, remember, on a unit circle, the hypotenuse is always 1, so the cosine of theta is actually just going to be negative 8 over 15ths, okay? And what do you know? Negative 8 over 15th happens to also be the x-coordinate of the red point, right? So now I've concluded that if I have a unit circle, a circle with a radius of 1, the red point x-coordinate is equivalent to the cosine value. Okay? So if they give me a pair of points like this on the unit circle, the first value is equivalent to the cosine of theta. And the second value is equivalent to the sine of theta, because you can see that like the vertical side is 15/17, right? So that would mean the opposite side, the side opposite to the angle, is equal to the numerator, right? Which would be 15/17. And what is the, I'm sorry, this is an H, it's not an A. I'm going to rewrite that because it's very messy. The hypotenuse in a unit circle is always 1. So it's 15/17 divided by 1. So the sine of theta is 15/17. And what do you know? 15/17 is also the y-coordinate of the red point. Okay? So indeed, the x-coordinate of the red point is always cosine of theta, where the angle that forms the hypotenuse of the triangle is theta, okay? And the y-coordinate of the red point is always sine of theta, okay? So whenever they give you the coordinates of a point, x comma y, if it's on the unit circle edge, then that means that the first coordinate, the x-coordinate, is cosine of theta, and the second coordinate is sine theta. So they're actually asking you a very simple thing. They're saying, give me the cosine of theta, given that we want to know for the theta that's drawn here, which corresponds to the red point. So we're going to say it corresponds to the x-coordinate, which is negative 8 over 15, right? It's the x-coordinate of this ordered pair. So when they ask us for the sine theta of this one here, we know that it corresponds to the second coordinate, or the y-coordinate. So we know for this one, it's negative 8 over 25ths. Okay, basically they're saying, it's another way of saying, give me the x-coordinate or the y-coordinate of a certain point. It's a different way of asking for it, right? Asking for the cosine or the sine of theta. All right, let's go down to number 3. Evaluate the expressions below without the use of a calculator. Use the sine, cosine, tan table above. Okay, so there's 3 angles here, and first we're going to do this one from top to bottom, then we're going to do this one from top to bottom, and then we're going to do this one from top to bottom. Okay, and if we follow the instructions, it's not as difficult as you might think it is. Okay, and I'm going to show you how to use the table when we do this. Draw the triangle corresponding to this angle in the unit circle, and then write down the reference angle. Okay, first of all, negative 210 degrees. Remember that 0 degrees is always this line here, which points to 3 o'clock on the clock, okay? Remember that 0 degrees is always this line here, because remember when you were in, like, you know, 3rd grade and you first used number lines, maybe it wasn't 3rd grade, maybe it was later, but our number line back then basically started at 0 and then started going up in the positive numbers, right? And it didn't go left because we didn't know negative numbers yet, right? So we only started from 0 and we went to the right. So this is the, like, kind of the beginning of the graphing problems that we did very early in our math careers, okay? Now, when we started doing two-dimensional graphing in like 6th or 7th grade, we worked only with positive numbers also. And the positive numbers, as you know, are all located here in this sector, right? In this sector here, which is called the first quadrant. So the first quadrant starts here because this is where we started in like 3rd grade. And then in 6th to 7th grade, we started working with this quadrant here. And so when we work with angles, that is why we start at 0 degrees here, and then we start counting to 90 degrees, going up and to the left like this. So 90 degrees is here, 180 degrees is here, and 270 degrees is here, and 360 degrees would be when you arrive back at 0 degrees again. Okay? Now, because that is the positive direction for angles, remember that the negative direction for angles starts here, and then like not negative angles would go in the direction opposite from the first quadrant, which is the quadrant we're most familiar with. And then it starts counting in the opposite direction. So this would be negative 180, this would be negative 270, and this would be negative 360, coming back to zero again from the opposite direction. Okay, so now we know how to figure out where the angles are in the positive direction and the negative direction. Since this is negative 210 degrees, I am going to start from 0 degrees here, and then I'm going to start counting this way because this would be a negative direction. This would be negative 90. This would be negative 180. I still haven't gotten to 210. This would be negative 270, so obviously I went too far. So negative 210 would be a little bit past 180. In fact, it would be 30 degrees more than negative 180, right? So it would be 30 degrees past 180, okay? And then I am going to use, I drew the hypotenuse to connect to the point negative 210 degrees. So this would be negative 210 degrees, this angle here, okay? And then I'm going to form a triangle out of this. Now remember, to form a triangle from this, I'm not going to connect it back to 0 degrees. What I'm going to do is I'm going to draw a straight vertical line from the red point to the x-axis, and then that makes my triangle. Okay, this is a right triangle, and now I'm going to figure out, what do they want me to figure out? Okay, so now I've drawn the corresponding angle. The angle is the red line here. And then it says to write down the reference angle. Okay, so remember how I said that if I go to this point here, then that would be 180, and I went a little bit past that, right? I went to here, to 180, and then I went a little bit past. How much farther past did I go of 180? Remember, it's negative 210. So 210 minus 180 is 30 degrees, right? So actually what I did was I went 30 degrees past 180. So my little triangle here, that my red and green triangle here, has as its angle that is close to the origin, it has 30 degrees. Okay, so my reference angle, which is always an angle between 0 and 90 degrees, happens to be 30 degrees. Remember that the reference angle is always measured from the hypotenuse, the red line, to the x-axis. So this would be 30 degrees and not 60 degrees, right? It's 60 degrees to the vertical line here, but we never measure reference angles to the vertical line. We always measure it to the horizontal line or the x-axis. Okay, so I can write down here that my reference angle for this case is 30 degrees. And then it says, using the reference angle, find the value of sine of negative 210. Okay, well, we know that the sine of the reference angle, 30 degrees, is, we'll just look it up in the table, okay? Sine of 30 degrees is 0.5. So we're going to come down here and say sine of 30 degrees is 0.5. The question is, what is the sine of negative 210 degrees? Is it also 0.5? It's related to 0.5, but like whenever you do one of these problems with the reference angle, the sine of the actual angle is going to be either the same as the sine of the reference angle, or it's going to be the negative of it. So our two choices are positive 0.5 or negative 0.5. Now how do we figure out which one is which? We can do that by looking at the triangle we created. The triangle we created has two sides. It's got a vertical side and a horizontal side. The horizontal side is in which direction? Is it pointing in the positive direction or the negative direction? Well, since it's pointing left, it's pointing in the negative direction, correct? So the adjacent here, the adjacent, which is the side that's next to the origin, is negative. And do you see how the opposite side, which is the vertical side, is going to be a positive number because it goes up, right? So the adjacent is negative and the opposite is positive. Now remember, the hypotenuse is always positive because the hypotenuse doesn't really have a direction. It's diagonal, so you can't really tell if it's positive or negative. It's always just 1, positive 1, okay? So the sine of this angle is the definition of sine, remember, is SOHCAHTOA. So the sine would be opposite over hypotenuse. The opposite in this case is positive. The hypotenuse in this case is positive, so the sign is going to be positive. So it's going to be positive 0.5. Okay, so the sign of negative 210 happens to be the same as the sign of the reference angle because it's sine of 30. Okay? All right, now let's look at, we're going to look at 240 degrees first because cosine is a little bit easier than tangent. All right, so first we're going to draw the reference corresponding angle in the unit circle. Okay, so we're going to write 240 degrees. This is 0, this is 90, this is 180, this is 270. So 240 is a little bit less than 240 is a little bit less than 270, so it would be this point here, and then I made it into a triangle by drawing a vertical line from the point, from the red point to the x-axis. So there's my triangle, and this triangle is 240 degrees, as you can see, positive 240 degrees, so it goes up from the x-axis. And then the reference angle would be this angle here. The reference angle in this case is the number of degrees past 180 degrees. 240 minus 180 is 60. So the reference angle would be 60 degrees. Okay, that's the reference angle. So I know that the cosine of 240 is related to the cosine of 60 degrees because 60 degrees is the reference angle. But what is the cosine of 60 degrees? Okay, so normally you go to your calculator and you say, okay, cosine of 60 degrees, and you type cosine of 60 and see what it is. But we don't want you to get the wrong cosine value, just typing in cosine 240 or whatever. So we're going to go back to the table and we're going to say cosine of 60. Cosine of 60, let's see, would be, look at this row, cosine, look at this column, which is 60 degrees, and our answer is 0.5. So cosine of 60 degrees is 0.5. The question is, what is the cosine of 240 degrees, which is not quite the same thing as the reference angle. So we're going to do the same thing we did as with the sine. We are going to look at the triangle, and we're going to see if the ratios of cosine, which are adjacent over hypotenuse, are positive or negative, and that'll give us the sign of the 0.5. Okay, so let's take a look at this. So do you see how this triangle here, it has a x-coordinate going in the negative direction and a y-coordinate also going in the negative direction, and the x-coordinate is the adjacent, so the adjacent is negative, and the vertical part is the opposite, and it is also negative. So actually, the cosine, which is adjacent over hypotenuse, would be a negative number divided by a positive number. Remember, the hypotenuse is always positive 1. So it would be negative 0.5. Okay? So we start with the reference angle's cosine value, which is 0.5, and then we change it to negative 0.5 because the adjacent for this case is negative. Okay? All right. And now let's do the final one, which is tangent, which is the most tricky one. Tangent of 135 degrees. So first we're going to draw 135 degrees. And 135 degrees is, it's a number that is 45 degrees past 90 degrees, right? So it kind of looks like that. Okay, I'm going to draw a little triangle out of it. Okay, and then I'm going to, and then I need to make the reference angle. The reference angle would be this angle here because the reference angle is always from 0 to 90, and it's of the triangle which is drawn between the red point and the x-axis. Okay, and in this case, since I want 135 degrees, and 135 degrees is 45 degrees past 90, then I know that the remaining angle here is 45 degrees also. So the reference angle happens to be 45 degrees. So when I'm trying to find the tangent of 135 degrees, I know it's related to the tangent of the reference angle, which is 45 degrees. So let's find out what the tangent of 45 degrees is in the table. It will be tangent of 45 degrees is 1. So we're going to put 1 here. Okay? So the tangent of 45 degrees is 1. Now the question is, what is the tangent of 135 degrees? Is it positive 1 or negative 1? So the way we figure that out is we're going to look at the triangle again. We're going to say, okay, the x the x direction of the triangle, the x coordinate of the triangle is going to be negative because it's to the left of the origin. The y coordinate of the red point of the triangle is positive because it's above the origin. It's up from the origin. So the opposite is positive, and the adjacent is negative. And remember, tangent is opposite divided by adjacent, right? TOA. So since the tangent is opposite over adjacent, we know that it's positive divided by negative. So the result will be negative. So, and then the value of the tangent is the same as the reference triangle, which is 1. Okay, so it will be negative 1. Okay, so that's it for page 1.